Hello, everybody. Really amazing day today. It is all about the unit circle, just this little teeny circle, radius 1. Amazing how much trouble you can get into. So the goals, we're going to fill out the unit circle with angles, sine and cosine values. So all of a sudden we have these radians and degrees. We have this circle, and then we have we're basically going to create a tool that allows us to find the sine and the cosine of any angle, but more specifically these exact value angles that we're going to use over and over and over again, like 30, 60, 45, and then all the multiples of those. So, well, all the multiples of 30 and 45. How about that? This is a 2-day deal. 2-day deal. Don't freak out. Um, so this is going to be over the next 2 days. Today we kind of introduce it, hopefully plant the seed, and then we've done this a couple days now. Just want to make sure you feel good about it, and then we'll actually use the unit circle and determine sine and cosine values of the various angles. Um, this goes without saying, so important. Let's see if I can. Oh. Goes without saying how important it is to understand the side lengths of a 30, 60, 90 triangle and a 45, 45, 90. I was just showing off there that pi over 4 is 45 degrees. You should know that. You're already 1 day into it. You should be like fluent. All right, so at this stage, you should know that that is 1/2, and that is the square root of 3 over 2. Those are lengths of a 30, 60, 90 triangle when the hypotenuse is 1, and that's all we're going to deal with is hypotenuse is 1. Over here, we're not going to use r. We're going to use the radius is equal to 1, always. Radius, whoops, am I slipping there a little bit? The hypotenuse. And this is the square root of 2 over 2, and the square root of 2 over 2. Also known as 1 over the square root of 2. So if you see that, know it's the same thing. Um, I'll flop them both back and forth. All right. Hey, just to let you know, your goal at the very end, this is number 3, I think, on your homework, is to be able to fill out a box like this. First of all, from yesterday or the day before, can you translate those angles into degrees? Notice that they're very nice angles. They're always going to be multiples of 30, 45, and that's nice. But then for some reason, we should have this method that we can find the sine of 30. They say use your calculator, and they're saying, hey, when you get 0.707, please understand that's square root of 2 over 2. And when you get 0.866, that's square root of 3 over 2. And when you get 0.5, that's equal to 1/2. Duh. So that's lame. There's so much better of a way to do it. You should notice that, hey, I've seen square root of 2 over 2. I've seen square root of 3 over 2. They're sides of a right triangle. All right, so keep that in mind. Keep that in mind. All right, draw your first unit circle. Beautiful. You can take a compass. You could, usually I dress up in class to do something like this. This is an amazing day. And we're going to force the radius of the circle to be 1. Perfect. That is a slam dunk. That is nice. I don't even know if I just kept that the whole slide itself. That is beautiful. All right, well, let's see what mischief we can get into. All right, so first of all, we're going to start measuring angles on this unit circle. So this point P right here is going to slide around this circle. Great. Well, what we want to point out here is on this particular slide to illustrate that a 0-degree angle is right here. That is a 0-degree angle on this picture. And as we rotate it up in the positive direction, we get those positive angles. So that's the critical idea there. Positive for anti-clockwise. We call it counterclockwise. The book calls it anti-clockwise, and that is moving that way. And then negative angles, which are fine, -12, and so forth. In fact, I have a picture of some cool looking angles just to make sure. This is out of your homework. They asked you to do some things from these pictures, but I thought the pictures represent, if I say a 26-degree angle, notice I'm rotating that point up and getting that, and that is 26 degrees. And look at that, I can go to 146, I can go all the way to 199. Remember, a full circle is 180 degrees. Yes, we could be working in degree or radians right now, but degrees are a little bit easier because we're used to them. So there's 123 if you notice that. And look at this, a negative 35. So no big deal. It's all about direction. All right. So right now you should be able to, on a unit circle, show me a 30-degree angle. Show me a 45-degree angle. Show me a 90-degree angle. All right. So this is probably the most important slide that we're going to have. I'm focusing in the first quadrant. This works for the whole unit circle. So you might want to take your time, make sure you get a good picture here. All right, let's go blue. And I'm just going to pick a random angle. And we're going to make this theta. Okay, what's cool about this is we know it's a unit circle, so we already know that this is equal to 1. That is the radius of the circle. I'm really interested in the coordinates of that point, and that we can call it P, and we say that has coordinates X and Y. Okay, let's go ahead and draw X and Y. So here's the X, and here's the Y. Gosh, it almost looks like a 30, 60, 90 triangle. It isn't. It isn't, but I'm just saying, we've seen pictures like that before. We know some lengths of some very special triangles, but in this case, we don't. All right, so at the very beginning of this year, I talked about SOHCAHTOA. So we can solve for X here. We're going to solve for X in terms of theta. So it's not like we're going to get a number, but we're going to get an expression for X. All right, so if we're going for X, we can label these sides. This is the hypotenuse, the adjacent, and the opposite. So it looks like the cosine of theta will equal the adjacent over 1. Oh, wait a minute, over 1, that's just equal to X. Whoa, that's cool. So X will equal the cosine of theta. Interesting. I wonder what happens with the Y. So if we do sine of theta, we get the opposite over the hypotenuse. Oh man, I am absolutely loving that radius equal to 1. That is so cool. So the sine of theta is equal to Y. So what we're saying here, ladies and gentlemen, is we can also write this point as, instead of X and Y, we could say it's the cosine of theta and the sine of theta. So can we find cosine of an angle? Can we find sine of an angle? Yes, our calculator, all the time, always works. Cosine 30, boom. Cosine, sine of 30, boom. We would actually know those two lengths. Very cool, very cool. That's it, that's all there's to it. I know you're waiting for something else, but no, that's it. This is what you need to take away from. All right. So what's so valuable about the unit circle is we're used to triangles having an angle between 0 and 90. All of a sudden, this opens up a whole new world. New world. We can now define the sine and cosine of angles greater than 90 degrees. We don't have to rely on SOHCAHTOA anymore. We can rely on the unit circles depiction of sine and cosine. Sure, we use SOHCAHTOA to get there, but now all we do is remember that no matter where this point P is, those coordinates will be equal to this and this. So if we go over 90 degrees, if we were to be able to determine the coordinates of that point, then we would know the cosine of that angle and the sine of that angle. Seems easy. Well, now you understand that if you try the sine and cosine of a number that's greater than 90 degrees, let's say 120, sometimes you get positive and negative values. Well, that's just the positive and negative x or y values. Very cool. All right, so speaking of positivity and negativity, what we want to do here is kind of decide if the angle is between 0 and 90 degrees, it would be right in here. Okay, so 0 less than theta, I should just use less than 90. So in other words, if we were a point on the unit circle, what would the x be and what would be the y be? So x would be greater than 0 and y would be greater than 0. But what that is saying is that if x is between 0 and 90, then the cosine of theta is greater than 0 and the sine of theta is greater than 0. Cool. Let's check out another quadrant. This is quadrant 1, by the way. This is quadrant 2. It's quadrant 3, quadrant 4. Some people are like, which way is it? Well, that's the way it is. If we look at quadrant 2, then, so we'll write quadrant 2. We know that the x will be less than 0 and the y will be greater than 0. What am I looking at here? Any point on the unit circle, I'm looking at the x coordinate and the y coordinate. Well, to get over here, I need to go to the left. That's forcing x to be negative, and then up, that's forcing y to be 0. But we don't really care about that too much. What we want is the cosine of theta is less than 0, and the sine of theta is greater than 0. And quadrant 2 is defined as 90 less than theta less than 180. And I'm using degrees because we feel comfortable with degrees. I'm sorry, I should say pi over 2 less than theta less than pi. That's another way to say it. All right, I'm hoping that you can figure that out for 3 and 4. Part of your homework is to determine sine and cosine positivity in each quadrant. Should help you out. All right, periodicity. That means when things repeat itself. We are hoping that our PQRST wave of our heart repeats itself. So we'd say the period of that is that length of time that it takes to go through that PQRST wave. Okay, so there's a lot of things that are periodic. How about the ocean, the tides that go in and out every 12 hours or so? Sometimes it's different. So periodic things happen around us all the time. And it just so happens that this is a mathematical idea about period. So if we have theta and we add 360 degrees to it, or we add 2 pi, remember either one is a full circle, then we get theta plus 360 would get us to the exact same place as theta. All right, so we could say that the cosine of theta plus 360 is going to be equal to the cosine of whatever theta was. That's pretty cool. What's that? What that is saying is if I have the cosine of 30, I know that that's equal to the cosine of 390. All right, so sometimes you can use this to simplify it. If I have somehow caught the cosine of 390, I could say, you know what, I'm just going to do the cosine of 30, and that's the same thing. So of course, I could go around circle 3 or 4 or 5 times. So that's what that formula is all about. It's saying I can go with that angle and I can do the 2 pi is a full circle and k is like the number of times around. So 2 pi, think of that as a full circle. K can be 9. Well, take your angle, go around 9 more times, but you still end up at that same spot. So those x and y values have to be the same. All right. All right, so we're really at the end, to tell you the truth. Now it's like, hey, can you use the unit circle to find these values? So, well, we need a unit circle. You're going to sketch this a lot. I have a really good story about perfect circles, so I'll tell you that hopefully this week. So first of all, where is negative 270? Well, remember we start here at the positive x-axis. Negative means we go in this direction. So there's 90, there's 180, and there's 270. So are you going to want to know where these angles are to get there? Yeah, you are. Do we know the coordinates of that point? Well, yeah, the radius is equal to 1. So the coordinates of that point are 0, 1. Well, I know that the cosine value is equal to the x coordinate, and I know that the y value, or the sine value, is equal to the y value. Okay, so the cosine of negative 270 is equal to 0, and the sine of negative 270 is equal to positive 1. Oh, Mr. Sayers, I can use my calculator. Yeah, we can all use our calculator, but we gotta kind of get a feel for it. So don't use your calculator. Let's try another one. What is the cosine of pi? So the cosine of pi is, well, what's the angle pi? Well, we start at the positive x-axis and we rotate positive, so that's in the anti-clockwise. We go pi is exactly 180 degrees. So our point here is right here. We know the coordinates of that point are negative 1, 0. The cosine is the x coordinate. So we would say that's negative 1. And the sine of pi is equal to 0. So please understand, there's nothing easier than those four values, 0, 90, 180, 270, plus, minus, whatever, any multiple. You know the coordinates of that. What gets a little sticky is trying to find the coordinates of all these. Yeah, you might need your calculator for those. Except, all right, we'll skip that. I'm getting into it a little bit. There are some exact values. Let's look at this angle right here. Let's call it 30 degrees. Okay, so I'm saying that right there is 30 degrees. That is pi over 6 radians. Okay, it sure would be nice to know that x coordinate and that y coordinate, so I could write those in right there. Then I would know the cosine of 30 would be this value, and the sine of 30 would be this value. Well, what in the world do I have over here? Haven't I been pushing the 30, 60, 90 triangles a lot? Especially when the hypotenuse is equal to 1. Do you see how that fits in so nicely? So do we actually know the x and y coordinates of 30 degrees? You bet. This is square root of, whoa, whoa, whoa. This is square root of 3 over 2, and this is 1/2. So I can say with all the confidence in the world that the cosine of 30 is equal to square root of 3 over 2, and the sine of 30 is equal to 1/2. Hmm. I wonder. Wonder. Blah, blah. Why? Why is this? Oh, there we go. So that's pretty cool. That works out really well. Gee, I wonder, what is this? Remember the other angle of a 30, 60, 90 is the 60 degree angle. And we'll just write it like that. There you go. So look at that, a 60 degree angle also gives us a 30, 90, 60 triangle, also has a hypotenuse of 1 or a radius of 1. And now the x coordinate turns out to be 1/2, and the y is square root of 3 over 2. No way. So you could tell me with all the confidence in the world that the cosine of 60 degrees is the x coordinate, or 1/2. All right, all right. No way, Mr. Sayers. No way. You are not going to do this to us. There couldn't be more. Yes, there's more. Whoa. freaking out. The 45, 45, 90. We love 45, 45, 90 because the X and the Y are exactly the same, always. You just got to figure out positivity and negativity. In the first quadrant, they are going to both be square root of 2 over 2, square root of 2 over 2. So any multiple of 45, like the odd multiples, not 90, not 180, are going to be square root of 2 over 2. Sine and cosine are both going to be square root of 2 over 2. You just got to figure out if it's positive or negative depending on what quadrant you're in. Whoa! All right, I went a little bit further than section 10C, but I don't want you to plug in things in your calculator, get a number, and not like start to try to visualize what's happening. Visualize what's happening. So the final thing here at 20 minutes is you can really see the whole, this is a tool that you can use and reference, but what you want to do is understand that if I know two triangles, 45, 45, 90, 30, 60, 90 triangle, I can kind of visualize what the X and the Y have to be. All right. So if, let's just, I'm running out of time, so I don't want to, if I wanted to say 330 degrees, 330 degrees is all the way to here. So the coordinates of this point right here are going to be the cosine of 330 degrees and the sine of 330 degrees. Mr. Sayers, is that the same thing as negative 30? Yeah, I could say negative 30, absolutely. So what is the x coordinate? Well, it's this length. This is a 30, 60, 90 triangle. That's the longer of the two. So I know that's square root of 3 over 2. And I know this is the other length of the 30, 60, 90 triangle. So that is 1/2. But it's negative. See how it's going down? So I have to make sure I write a negative 1/2 there. So this is 330 degrees, and I believe that is 11 pi over 6. So with all the confidence in the world, I could say the cosine of 330 degrees is equal to square root of 3 over 2, and the sine of 330 degrees is equal to negative 1/2. All right. I know it's a lot and it's not, oh, I get it. You're going to get it. It's going to take a week or two, but I am going to push that you visualize what's happening so you don't have to memorize all these different values. Because if you know those two triangles, you can fit them at all these exact values. All right, you guys are awesome. That is your homework. I guess we'll put in a play posit there. Well, let's just put in I'll put in a question about what do you have a question about, and life should be good. Thank you.